So our next section is proving triangles are similar. So we're not going to have to do any proofs. However, we are going to have to use our math and proportions to show that the triangles are similar. So a little bit different, sorry about that, a little bit different than congruence. So similarity, we have angle-angle similarity. So that means that you have to have at least two angles congruent in a triangle. Then the triangles will be similar. Side, angle, side, you know what that is. Now the difference is with sides, they don't have to be congruent. The sides have to be proportional. So if we look here, we have our two sides have to be proportional. So that means if we have our fractions, they have to be equal. And then the angle in between them has to be congruent. And that would be side, angle, side similarity. So that's the only difference there between congruence and similarity is congruence, we would have sides be congruent, but now when we're talking about sides, we're talking about them being proportional. So same thing, we're going to have side, side, side similarity, but again, the sides don't have to be congruent, their sides have to be proportional, meaning if I put the sides from one triangle over the sides from the other triangle, the proportions should be exactly equal. So we're going to look at a few examples. The first one here, we're trying to determine if it's similar, and then we're going to give a similarity statement if it is. So our first one, we have two triangles here. We've got triangle DBE, and we have triangle ABC. So I'm going to break them up. So I'm going to do the smaller one and the bigger one over here. Now, the angle that they share is here in the middle. If we look, they both have angle B. So we already know that we have one angle. So we're either going to use side, angle, side, or we're going to use angle, angle. Now it's going to, knowing that they give us the sides, that means that we're trying to show that it's going to be side, angle, side. So I'm going to fill in my triangle here. I know DB is 8 and BE is 4. AB now, AB, if we look here, AB is not just 10. AB is the whole thing. So we have to do 10 plus 8. So that's going to give us 18. And then BC, have to do the whole thing again. So we're going to do 4 plus 5, which gives us 9. And we know that they have this angle congruent here. So I'm going to set up the proportions. I'm going to do small triangle to big triangle. So I'm going to do DB is to AB as BE is to BC. And I'm going to fill in the numbers. So if I fill in the numbers, DB is 8, AB is 18, and then BE is 4, and BC is 9. So looking at them, they don't look similar. However, if we simplify this down, divide the top and the bottom by 2, then we get 4 over 9. So since we have 4 over 9 and 4 over 9, that means that our sides are proportional. So these sides are proportional, and we have an angle in between. So by side, angle, side, we know that triangle ABC is similar to triangle DBE. Okay. And so similar symbol is just that little part of the congruence symbol. So no equal sign underneath, just a little squiggly line there. For our next example here, we've got two triangles again. So I have 40 and 40, and we know that there's 180 degrees in a triangle. So I know that this angle has to be 100, and same thing here, I have 100 plus 40 gives me 140, and if I subtract that from 180, I need 40 more to get to 180. So actually we have all three angles are congruent, but we only need two. So we can say by angle, angle, that triangle ABC is similar to triangle DEF. And then our next example, same thing, we're going to try to do ABC is similar to DEF. So we have to check that the sides are all proportional. So we know we're not going to do angle, angle because they don't give us any angles. And we're not going to do side, angle, side because again, we would need an angle given. So we're going to do side, side, side. So I'm going to match up. I'm going to do AB with DE. And that's going to be equal to BC and EF. and then DF, or sorry about that, AC to DF. So I'm going to fill in the proportions accordingly. So I've got 40 is to 4, as 50 is to 5, and as 60 is to 6. And now we know if we simplify this down, we get 10, 10, and 10. So since they are all proportional, we can say by side, 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 that triangle ABC is similar to triangle DEF. And our last example here, we're going to actually have to solve for some variables. So I'm going to outline each triangle in a different color. Because again, when they don't have letters, it's kind of hard to make sure we're setting the proportions up right. So first what we're going to do, we're going to start where we have 2 numbers on those sides. So if I look here, my bottom side here has an 8, and my bottom side in the other triangle has a 12. So I'm going to use that so that way I have a whole fraction on one side, because then I can solve for a missing variable. I'm going to start with x, and then I have to look in the other triangle to see what would match up with x. If we look here, x is on the horizontal, the diagonal line here. So is 15. So I'm going to do x over 15, and then I can solve for x. So I'm going to do 8 cross multiply. I'm going to do 8 times 15, and that gives me 120. And 12 times x gives me 12x. So x will equal 10. Now I have to figure out y. Again, I'm going to start with my 8 over 12 because that's just a given proportion from the problem. And then we're going to do, now we have to pay attention here because if we're starting with the red triangle, we have to start with 5 on top over the y. And again, I'm going to cross multiply. So I'm going to do 8y equals 60. And then if we divide both sides by 8, we get y equals 7.5.